Hi, 5th graders. I'm Jacob Hoyt, captain of 18529 Rust in Peace. I hope you Lucky Ducks had a fun time playing around with the Teleop, part of the Virtual Robot Simulator. Today is the day where we start the actual programming. Before we begin, it's important I remind you that this program is used by high schoolers. So if you struggle a bit, that's okay. This stuff's hard, even for me. Learning to code starts with some basic steps and gets more complicated. Coding is super useful in many aspects of one's life. A basic foundation in coding, also known as programming, is important because it enables you to show and make your ideas actually happen. All you need is a rough draft of your idea, and it can lead to amazing new innovation and collaboration opportunities and help you continue to grow and improve. Okay, have you ever wondered how humans tell machines what to do? Machines might seem to work via magic, but that magic is actually thousands of lines of computer code. You might be wondering, what is code? Well, computer code is how humans talk to computing machines, which nowadays include desktop computers, laptops, phones, tablets, video game systems, robots, satellites, ice cream machines. The list goes on. At the heart of all these machines are microprocessors, which are the brain of a machine. Unlike our brains, which evolved over billions of years, machine brains were created by human scientists about a century ago. Microprocessors control the flow of electricity in a computing machine, and by talking to them, we can tell them what to do. Microprocessors might tell a light to turn on, a phone to vibrate, the color of pixels to change, or, in our case, a robot to start moving. Programming blocks combine the simplicity of building Lego-like blocks with the power of writing in a programming language like Java. By stacking and combining blocks, you're able to write computer code that a computing machine, like a robot, can understand. While the Virtual Robot Simulator uses a virtual robot, the computers that run the Virtual Robot Simulator interpret machine code in a similar way to the physical robot. They just control the virtual parts instead of physical parts. Otherwise, the code is the exact same. The key to learning most things, including block programming, is starting with simple tasks and then building outwards to solve harder and harder ones. This is exactly what we will do with the VRS. We will learn a new task each class period, then give you time to practice it. So let's get started. Our first task will be to move the robot forward and backward.
When you open up the VRS app, you're going to see two options. We're going to open up the autonomous section for today. When you open up the autonomous section, you're going to see three main sections on your screen. The left section of your screen is dedicated to your code. Over here on the lower right side of your screen is the game. This is where you'll see that your robot do the things you've coded it to do. Finally, at the top right is where the robot can tell you information. We're only going to worry about those first two zones for today. At the top of your screen, make sure you notice all these buttons. These buttons will start, stop, and reset the game. There are a couple of really important blocks that you guys are going to be using a lot. One of them is timing blocks called linear op mode. We also need to know about the actuator blocks, or motor blocks. These turn on the different motors on your robot. You guys are going to need many other blocks in the future, but just for today we can focus on these two. Today, we're going to start actually making our robot move. We're going to start by simply having our robot drive to the white line. For today, you can get rid of all these green blocks. We're then going to grab all the blocks we're going to need for the program. We're going to need a timing block and two motor blocks, one to turn the motors on and then one to turn them off. We're going to start the program by turning the motors on the robot on. Then, we're going to have the robot wait before turning them off. Now that we have some code, we can click the Start Program and see if it works. We were really close this time. We can add a bit more time before the motors turn off to make our robot drive farther.
Next, I get rid of this green thing. You can just delete it. Then we're going to get a time break block. Next, we're going to get a double motor that will make the robot move. We're going to pull down double motors out from the side. Then we're going to drive and put the motors in. We're going to wait and turn the motors off. Finally, we start our program and see if it worked. So I hit start. Did it go to the white line? Not quite. So now is where you just have to keep trying over and over. First, I can try changing the time the motor runs so it moves for a little longer time to get closer to the line. To test it out, you set the field again and then start the program. Did it work? Well, it's a little bit better because it's almost to the white line. Let's try again and add another 100 milliseconds to the block of time by switching the numbers. Let's try that out. I will set the field and start the program. This time I got pretty close to the white line.
Good luck, and remember, it will take lots of practice, so don't get frustrated. See you in a couple of days, 5th graders.